Hello, BIO178. Do I always do a double wave? I don't know. I might sometimes. Welcome to our week 5 lab. And this lab is exciting. Of course, I'm biased, but we'll actually be working with some data from the work that I do. This is some high throughput sequencing data from the intertidal snails that I work with. And like we've talked about in lecture, you can obtain molecular markers such as SNPs from high throughput sequencing data through a sequencing technique such as RADseq, and that's actually what we're going to be working with today in lab is some SNP data obtained from RADseq. And what we'll focus on in this lab to correspond to the lecture topics is looking at different metrics of genetic diversity for these different snail populations. And this lab is a little bit different in the sense that what we're going to be focusing on is thinking about how to interpret the statistics that we get back and which one is most appropriate for our particular data set. So like I said in lecture, I don't want you to know how to hand calculate Hardy-Weinberg equilibrium or anything like that. There are ways to do that in R, which is what we're actually going to be doing in this lab. We're going to use a particular R package to calculate a bunch of those different genetic diversity metrics for us. So allelic richness, observed heterozygosity, those kinds of things. So that is relatively easy in the sense that it's literally one line of code with you have your input file, one line of code, you execute that, and you get a summary table of the different genetic diversity metrics. What I want us to focus on is thinking about how to interpret that data. And that's for a couple different reasons. Like I believe I mentioned in lecture, one of my anecdotes from my PhD was I didn't really know what I was doing with this type of data. I just thought that, oh, if it's out of Hardy-Weinberg equilibrium, that must be bad, so I should get rid of it. And my advisor was like, no, don't do that. So what I want us to focus on is thinking about how to interpret these different metrics. It's easy to calculate all of them, but do all of those metrics in terms of genetic diversity actually make sense for the particular data that we're looking at? And so I want us to focus on that interpretation and critical thinking about that data, because that's also what I'm going to ask you to do when you're writing your proposals. So for instance, if you wanted to propose to investigate the genetic diversity of different populations, you'll need to understand which of those metrics is most appropriate for your particular data set. So that's what we're going to focus on and think about in this lab. So we're corresponding to lecture topics about single populations and genetic diversity, but we're focusing, in addition to just logistically how to do it in R, also how to look at it on the back end and figure out what it actually means so we can be informed and make logical decisions about which of this data to actually interpret and use based on our particular data set. So again, hopefully this is fun if you like snails. At least some of you like snails. So go ahead, click through the module and it'll walk you through with written instructions and tutorial videos, just like always. If you have questions, reach out. I'm happy to answer them. And I hope you're all doing well and have a good rest of your day doing the lab and then whatever else you might be doing. Okay.